Types of semiconductors. Intrinsic semiconductor. An intrinsic semiconductor is one which is pure enough that impurities do not appreciably affect its electrical behavior. Example: germanium and silicon. At room temperature, the valence electron absorbs thermal energy and get excited. Due to absorption of energy, the valence electron jumps from the valence band to the conduction band. Whenever a valence electron drips from the valence band to the conduction band, a vacancy is created in the valence band, and such a vacancy is called a hole. Thus, an electron-hole pair is produced. Now, if a potential difference is applied across a semiconductor, current will flow through the external circuit. Electrons and holes flow in opposite directions in an electric field, though they contribute to the current in the same direction since they are oppositely charged. This type of semiconductor, where the conductivity is due to the movement of electrons and holes, is called the intrinsic semiconductor. Thus, equal numbers of electrons and holes are present in an intrinsic semiconductor. Extensive semiconductors. Conductivity of intrinsic semiconductor is very less at room temperature. To increase the conductivity, a small amount of external impurities added to the pure semiconductor. Such a semiconductor then becomes impure or extrinsic semiconductor. The process of deliberate addition of a very small amount of impurity into an intrinsic semiconductor to increase its conductivity is called doping, and the impurities are called dopants. Impurities are classified into donor impurities and acceptor impurities. Donor impurities are those elements which donates excess electron for conduction. Pentavalent elements like antimony, phosphorus, arsenic are donor impurities. Acceptor impurities are those elements which creates positive carriers or holes that can accept electrons. Trivalent elements like boron, gallium or indium are acceptor impurities. Dominant carrier concentrations in an extrinsic semiconductor classify it as either an N-type or P-type semiconductor. N-type semiconductors. If a small amount of pentavalent impurity is added to an intrinsic semiconductor, then 4 of the 5 valence electrons form a covalent bond with the 4 valence electrons of the intrinsic semiconductor, and the 5th one will be available for conduction. This type of semiconductor, where electrons are the current carriers, are known as N-type semiconductor. The phrase N-type comes from the negative charge of the electron. In N-type semiconductors, electrons are the majority carriers and holes are the minority carriers. N-type semiconductors are created by doping an intrinsic semiconductor with donor impurities. Now, when an electric field is applied, the current flow is shown in the animation. In an N-type semiconductor, the Fermi energy level is greater than that of the intrinsic semiconductor and lies closer to the conduction band than the valence band. P-type semiconductors. If a small amount of trivalent impurity is added to an intrinsic semiconductor, only 3 covalent bonds are formed, and there exists a vacancy in the 4th bond, creating a hole. This type of semiconductor, where positively charged holes are the current carriers, are known as P-type semiconductor. The phrase P-type refers to the positive charge of the hole. In P-type semiconductors, holes are the majority carriers and electrons are the minority carriers. P-type semiconductors are created by doping an intrinsic semiconductor with acceptor impurities. Now, when an electric field is applied, the current flow is shown in the animation.